Good morning. This session I will be discussing mean deviation in statistics, better to say in descriptive statistics. Mean deviation is a topic which you need to know, which comes under the chapter dispersion. Mean deviation or mean absolute deviation is the measure of dispersion from a fixed number. What is this? When you are doing some statistical analysis, how measured values are deviated from mean or median or mode, any central tendency is a requirement when you are doing any statistical analysis. So here in this topic, I will be discussing how the dispersion can be calculated. Dispersion means how much those measured values are scattered around a fixed number. What is that fixed number? See, in statistics what you do, you calculate mean, median, mode, all these things. And mean is the representation of all the values in statistical analysis. So when you are considering the mean as the representative of all the values, you need to know how much faithful representation going to be. But normally all measured values are little bit deviated from the mean. Similarly, it may be deviated from median, it may be deviated from the mode. That's why we will calculate mean deviation about the mean, about median, about mode if it is required. But there is a problem here calculating the mean deviation. If you say that I will calculate about the mean, you may not get the success. You will find the deviation coming to be equal to 0. Why? If I am taking, suppose a set of data given this manner, just you take an example of first 6 natural numbers. 1, 2, 3, 4, 5, 6. What is the mean of these 6 natural numbers? 6 into 6 plus 1, that divided by 2 into 6. So this is going to be 3.5. Now what is the deviation of 1 from 3.5? You calculate 1 minus 3.5, that is minus 2.5. 2 minus 3.5, it is minus 1.5. 3 minus 3.5 minus 0.5, 4 minus 3.5 plus 3.5, 5 minus 3.5 plus 1.5 and 6 minus 3.5 plus 2.5. So when you are calculating sum of all these deviations, you can see that 0.5 get cancelled with minus 0.5, 1.5 with minus 1.5, 2.5 with minus 2.5. So here deviation, if we do not modify these signs, deviation about the mean is going to be equal to 0. Why? Because net deviation is 0. So when you are going to calculate mean deviation about mean, the sum is equal to 0. So deviation about the mean is equal to 0. But when you think about the deviations, really deviations are there. The data deviated from the mean. But how much deviation is there? That is not found as you are calculating deviation about the mean. Their sum is going to be 0. That's why when you are going to calculate the mean deviation about mean or about any point, you need to get the deviation, absolute deviation. That's why we sometimes refer this deviation as MAD. MAD means mean absolute deviation. Okay. So mean absolute deviation, when you find absolute term means we will make these negative quantities positive. Then there is a meaningful deviation about the mean. For this example only, for first 6 natural numbers, if you calculate mean deviation about the mean, then you calculate net deviation, you make all these things positive. So sum of all the deviations is equal to 2.5, we made this one positive, plus 1.5, this one made positive, plus 0.5, and this will be multiplied by 2 because this data repeats over there. 2.5 is there, so there it will be 4.5, that is 9. Sum of all the deviations going to be equal to 9. So what is the mean deviation about mean here? So MAD for this mean absolute deviation is going to be sum of all the deviations by 6. So this is 1.5. Okay. So in this chapter we are going to find MAD, mean absolute deviation, not only mean deviation. Let us know the formula first properly. We are going to symbolize the formula, the concept we got here. We will do the formula based on the concept. So suppose for a simple distribution where frequencies are not given, suppose n observations are given like this, x1, x2, xn, n observations are there. Mean of these observations be x bar going to be what? It is sigma xi by n, all of you know it, I equal to 1 to n. Now you calculate all the deviations. You take deviations as di. Di, for first di, the general formula will be xi minus x bar about the mean. So d1 is going to be mod of x1 minus x bar, d2 going to be mod of x2 minus x bar, this way dn mod of xn minus x bar. So we found all the deviations. Now what we'll do there, we'll find sum of all these deviations. So sum of all the deviations is equal to d1 plus d2 plus this way up till dn. If we use this data, then it is going to be x1 minus x bar plus x2 minus x bar this way plus xn minus x bar. Using summation symbol, this can be written as mod xi minus x bar I equal to 1 to n. So this is sum of all the deviations. Then for simple distribution, formula for MAD, mean absolute deviation, going to be sigma I equal to 1 to n mod of xi minus x bar, that divided by n. This is mean absolute deviation for a simple distribution, which we have already used for finding mean absolute deviation about the mean for the first 6 natural numbers. Now this is mean absolute deviation about mean, but it may be about any point, any measure of central tendency. So mean absolute deviation about a point A If we want to find, we will replace x bar by a. This is given by sigma I equal to 1 to n mod of xi minus a that divided by n. So any set of observations given, you can find it by this formula. Now, if group frequency distribution is there, then mean absolute deviation about a point A. Another thing, this A may be for median, MAD about median. If we symbolize median term by M, capital M, then mean absolute deviation about median will be sigma I equal to 1 to n mod of xi minus m that divided by n. Okay. Similarly, we can do it for mode also. Now let us know formula for grouped frequency distribution. If frequency distributions are given, like suppose this observation x1 is coming f1 times, x2 coming f2 times, and xn going to be fn times, then mad about the, I am writing about the point A, about the point A will be sigma I equal to 1 to n fi into mod xi minus a that divided by sigma I equal to 1 to n fi. Okay. Sum of all these frequencies are to be added in denominator. So you understand the meaning of mean absolute deviation about the point A. That A may be mean, A may be median. So let us take one example where frequency distribution will be given and we will be finding the mean absolute deviation about the point A. Suppose you are going to find mean absolute deviation about the mean for this data. Then we will do it for median also. Let us do it for about the mean first. So what we will do here, class interval we will write in one column and then frequency in another column. Then we will find the mean value. These mean values are actually xi. Then you will find di equal to xi minus a. Then you will find mod di. Then you will find fi into di. Fi into mod di. Fi into mod di means fi into sigma xi minus a. And here the data you will get which is sigma fi into mod di. And here for frequency, if we symbolize it by fi, we will be getting sigma fi. Okay. So let us proceed. We are finding mean first. Without finding mean, you cannot do it here. That point A is not specified. So we need to get the mean first. Can you find mean by this form here? No. For finding mean, we need to get fi into di. We are finding fi into mod di for the mean absolute deviation. But we need to find the mean first. So 1 to 10, 11 to 20, 21, 30, 31, 40, 41, 50, 51, 60, this is 11, 29, 18, 4, 5, 3. The mean value of these things you need to find, it is 5.5. This is 15.5, 25.5. This is 45.5 and this is 55.5. You find di equal to xi minus a, you take any one of them as assumed mean because we are paying attention to find the value of fi into di. this mod di we will find in the next column. Okay. So let us find the value of ti. I mean, let us take the absolute, the value of a as 25.5. So when you find di equal to xi, these are called xi. When you find di equal to xi minus a, this will be 0, minus 10, minus 20, this will be 10, 20 and 30. Then ti going to be equal to di by h, length of interval, so it will be 0, minus 1, minus 2. This will be 1, 2 and 3. And then find fi into ti. If we do fi into ti, then sigma fi into ti is also required. Fi into ti, this is going to be what? This is minus 22, this is minus 29, this is 0, this is 4, 10 and 9. This is going to be 19, 19 for 23, 23 minus 28. So mean by step deviation method is given by assumed mean plus fi into ti, that sigma fi is 12, 30, 30 and 30. Here it is going to be 60. Just check once more. 8, 12, 12, 18, 30, 30. Then it is 41, 41 and 29. This is going to be 70 here. So sigma fi equal to 70. So this by 70 multiplied by length of interval, you can see it is 10. So this is going to be 25.5 minus 4, that is 21.5. So this is the mean of this observation. Now if we wish to find the value of mean deviation about mean in the same table, that we can continue. For this only we are going to find, in this table only we will find the value of, we need this part, I told you, mod di. We need mod di, we need, first we find di, then mod di, then fi into mod di. Okay. So let us find di first. Di means those values. Those values are already found. So we can take the help. I am rewriting here minus 20. But the thing is that this di is going to be different. That you found about the arbitrary point here. So you symbolize this part. This is fi into di. You take capital Di. Why? Because this time you are going to find mean deviation about the mean. So di going to be equal to difference between these two values, 5.5 and 21.5. This is going to be minus 16 minus 6. This is xi minus a, that is 4.5, no 4 only 4. This is 14. Next one is 24 and next one is 34. Okay. So this we got the value of di. We need not find sigma di. We need to find mod di. It is 16, 6, 4, 14, 24 and 34. Now find 16 into 11. That is fi into di you need to find. Fi into di going to be what? If you find fi into di, then this is 11 into 16, that is 176, 174, and then 4 into 18, 72, then 56, then 120, then 102. This is 700. So fi into di you got. Therefore, mean deviation about the mean is equal to sigma fi into mod di, this by sigma fi. Sigma fi you got earlier. So you find here that by using this table, sum you got sigma fi into mod di, mean absolute deviation you are going to calculate. So the answer is equal to 10. So by this method, mean absolute deviation can be determined, and in fact you can do it in the same table always. You find the mean and just extend it 3 more columns, you find fi into mod di, from there you can get. Now let